Hey guys, welcome back. So today we're going to work on a different project. Um, it's going to be us building our first VPC or virtual private cloud. Now this is going to be a bit different from the series of projects that we've been working on just because they are in the middle of updating some of the content. I don't know if you might recall. There were some instances where, like in certain projects, they had outdated data or outdated, just components of the project that were no longer working. So again, right now they're in the middle of updating those contents, and so we're going to just step away from that series of us building a CI/CD pipeline, and now we're going to focus on just this part of AWS, which has to do with networking. But for this specific project today, guys, we're going to do this one right here. Okay, so just bear with me. I know that they're working through this CI/CD pipeline this week. They're working on updating it, so hopefully by next time I post my next video, we'll continue with that series just so that we don't lose track. Okay, but again, we're going to step away from those projects, and we're going to go here to VPCs. Okay, so if you go here and I go to my projects, there is a series for VPCs which is called Amazon VPC series, and as you can see, there are like 9 parts. Yes, there are 9 parts. So for this specific occasion, we'll do the first one, and again, next time I'll probably go back to the CI/CD pipelines just so that we can finish that series of projects first. Okay, so just bear with me here. VPCs are a really how should I say, one of the main components of AWS. If you're studying for a certification, you'll see this a lot. So I'm really excited because it has to do with networking, and networking is one of the things that I'm really passionate about, that I really enjoy working with. So I hope you guys enjoy, and I think that should be all. Actually, one more thing. I noticed that I got charged for leaving some an EC2 instance running, and I got a bill for it. So guys, make sure that you are deleting your resources at the end of the project, just so that you don't get charged. And so yes, besides that, I think we'll go ahead and get this party started. Okay, so what are VPCs, right? It says it right here. You'll dive into the core of AWS networking by creating your very own virtual private cloud. Setting up and managing a VPC is a vital skill for anyone looking to master cloud infrastructure. So today you'll learn how to set up and configure a VPC from scratch. Okay, so what is a VPC? If we imagine your AWS region as a country, your virtual private cloud is like your own private city inside that country. So if you guys are familiar with traditional networking, right, and your local area network, right, in your LAN, you can have different subnets, right, for each specific department, right? So let's say we own a company, right? We're going to have a sales department, a marketing department, and we're going to have a, I'm not sure, a developers this team, right? So that's going to be another subnet. Now in this case with VPC, we had kind of like the same thing, where we're going to be having different subnets just so that we have a structurized way of separating different, or segregating or segmenting different teams or different environments, different resources. Okay, so that's what we'll be touching on in this project. Now it says it right here, right? you can design neighborhoods known as subnets, which you learn about in this project, and you'll be able to configure traffic rules and security measures to control how resources like EC2 instances and databases connect and work together. Right, so I guess you can kind of picture your VPC like a router or perhaps even a firewall, right? Because with these specific devices, you can do a lot of these things, right? So again, when you're thinking about VPCs, you can think about firewalls or routers in a traditional environment, okay? So this is a little bit of what it's going to look like at the end of the project. We're going to have our region, and within this region is that we'll create our first VPC. We'll create a public subnet, and we'll create an internet gateway. Now, what are we talking about when we say region, right? So if we go here to AWS and we click here, we have different regions, right? And I would assume that these are like different database, not databases, but data centers where they have these AWS services available to all of us, right? So when they're talking about here a region, right, just picture that that's a specific region within your continent or country or city, right? So then within that region, which is also referred as to your availability zone, you're going to have a VPC, right? Your virtual private cloud, and within this environment is that we can create certain rules and different settings to it. Okay, now one of the main things that we have to add here in this specific VPC or on these VPCs that we create is a public subnet, right? And a public subnet is pretty much like a route, right, that we create on our routing table. That's going to tell us if we are receiving traffic from this specific resource, or from this specific IP, right? I want you to forward that traffic to our next hub or our next target, right? So in this case, it will most likely be or an internet gateway, right? And the internet gateway is like your firewall, which will allow you to get access to the internet, right? So I hope that makes sense. That makes sense to you guys. I just wanted to give you a full picture of what we're going to be doing today. But let's go ahead and continue here. Feel free to watch that video if you like, and yes, that's it. Before we start, so what we're going to do first is create our first VPC. Okay, so we'll go here and we'll hit create VPC. Okay, so we are probably going to assign a subnet or a range of IP addresses that we're going to use, right? So we are there, and let's see, what is the point of having VPCs? Why do they matter? Let's see what they explain, how they explain it here. To put it simply, without VPCs, every AWS resource would exist in one giant open space in the cloud, like a country without cities or districts. Resources would be randomly scattered with no privacy or personal space, so everyone could see and access everyone else's resources. VPCs are the reason why resources can be made private to you. You also get control over resources in a VPC, so you can organize how they communicate and integrate with each other without the public internet. If we are still a little unsure about the difference between the difference a VPC makes, here's another analogy that might help. Imagine if every file in Google Drive from any account was put into the same folder with no privacy or subfolders. You'd have to find yourself among everything uploaded by everyone, which makes managing security your files really hard. That's what managing your resources will feel like without VPC. So again, right, in this VPC or virtual private cloud, we can have different resources. So we can have like multiple EC2 instances, and within each instance, right, you can have whatever, an application running or a database, and then it's within this specific VPC that you'll set these different rules so that they can communicate with each other, so that you can assign like different type of security permissions and access, and so on. Okay, so what are VPCs? So VPCs are in private environments that will allow us to secure our information from others and the internet. To secure our information resources from others and the internet. So make sure you are on the region that's closest to you. You'll notice that there is already a VPC in your account. Okay, so for me, it will probably be Ohio or Virginia. Yeah, I think Virginia should be fine. I mean South Florida, so that should be fine. Now it says right there that there is already this VPC, right? It looks like this is like a default VPC, right? It says default, but let's see if we can find out what that's about. So how is there already a VPC in my AWS account? I'm not really sure why. Let's see. So when you created your AWS account, AWS automatically sets up a default VPC for you. This default VPC is what you could launch resources, EC2 instances, for example, and connect services together from day one of using AWS. If it didn't exist, you would have had to learn how to create a VPC before you can use some of those services and the VPCs to function. Right, that makes sense, right? Because if you've been following my videos, creating the CI/CD pipeline, we never really had to create a VPC, right? It was something that we didn't really know about, and we didn't even know that we needed that to launch these resources. So the reason why we were able to create them or launch them is because there is this default VPC, right, that AWS automatically creates for us. This default VPC is a handy starting point, especially for beginners, but you can always create custom VPCs to fit specific requirements, and so on. So can I create anything in my AWS account without a VPC? You can use some AWS services like Amazon S3 or AWS Lambda without setting up a VPC. These services are designed to work on the internet without needing a private network setup. However, other services like Amazon EC2 or certain databases need a secure, isolated network to connect with each other and run securely. You would need a VPC in these cases. Extra for experts. Is my VPC the same thing as the internet? Nope. A VPC isn't the same thing as the internet. While the internet is an open public space and everyone can access, your VPC is private and isolated from the internet by default, right? Zooming out a little, the internet might be the most popular way to be online, but it's not the only one. Being online simply means being connected to a network that lets you communicate and exchange data with other people or servers. The broader space that includes every network is the cyberspace. Within cyberspace, we have different types of networks, like the public internet, private corporate networks, and cloud infrastructures. AWS is one of those cloud infrastructures, and your VPC is your private section of that infrastructure. You can connect your private city VPC to the internet with a tool called an internet gateway, which you'll learn more about soon. But a VPC is definitely not the same thing as the internet. Right, so that's a little bit of what I explained just a bit ago, right, where we have our cloud environment within the internet, or I'm sorry, within the cyberspace, which you could also say it's within the internet. And then, here is that you'll have your VPC. So we can have a VPC that will only work internally, and then you can have a VPC that will connect to an internet gateway that will grant you access to the internet, right? So I guess let me paint a picture for you here, right? So let's say that we build an application, right? This application will be hosted on an EC2 instance, right? And right, so let's say that our application needs to receive some type of updates or patches that are hosted online somewhere in the internet. For our application that's on our cloud infrastructure, on a private cloud, on a virtual private cloud, right? In order to access those updates or patches from the internet, you'll need to create a route that allows us to communicate with the internet, right? That allows our application, or to be more specific, our EC2 instance, to communicate with the network, with the internet, to make those updates, right? So that's kind of what we're seeing here. Okay, so why is there a default VPC in your AWS instance? There was already a default VPC in my account ever since my AWS account was created. This is because it allows us to deploy certain sources Okay, so let's go ahead and continue with the creation of our first VPC. So it says that we'll select only, we'll do the name tag next work VPC. So we'll do create VPC only, we'll give that name tag. Then we'll give this IPv4 CIDR, right? And then we're not going to use IPv6, and yes, that should be it, right? What's an IP address? I'm thinking that most of my audience are somewhat familiar with networking, the internet, but I guess we can go over it really quick if you're a completely beginner in this world of networking or internet or cloud or cybersecurity, right? So an IP address is like a unique street address or coordinates for the resources in your VPC. Your resources would use IP addresses to identify other resources to communicate and exchange data, right? So it's making reference to, like, let's say your street address, right? So your computer has a street address or has an IP address that would allow us, or will allow other computers to say, oh look, this computer has this address, so that's where we're going to go to communicate with that computer. So that's kind of like the way they're giving the example, right? Now it says here there are many types of devices and resources have IP addresses. It's not just AWS resources. Your computers, printers, smartphones, tablets, and smart home devices like security cameras and have their own IP addresses. Websites also have IP addresses. Well, we use domain names like Nextwork for convenience. These domain names map to an IP address that the internet uses to route traffic, and what makes this possible is DNS, right? Domain name services. Now, what is an IPv4? IPv4 and IPv6 are two different internet protocols, right, for communications. So it says here Internet Protocol version 4, which is the most common way to write an IP address. Is written as 4 sets of numbers separated by dots, right? Yeah, this is very basic. So, each number between the dots range between 0 and 255. This means IP addresses start from 0000 to 255 with so many combinations that are possible. There are about 4 billion possible IPv4 addresses. In general, two devices cannot share the same IPv4 address in the same work within the same VPC. Okay, now what is a CIDR block? It stands for classless interdomain routing. It is a way to assign a whole block of IP addresses, kind of like creating a zone area in a city. To understand how big a CIDR block is, look at the number after the slash. The smaller the number, the larger the CIDR block, right? So for example, if we have a network that's a 10.0.0.0/26, means that the first 16 bits of your IP address, right, which would be these two right here, are fixed, right? They cannot be changed. But the remaining 16 bits, which are these two zeros, right, the second part or the second half of the IP address, or in this case the subnet, right, it can be allocated however you like. Now, addresses within this specific range 16, right, they go from this 10.0.0.0 to this 10.0.255. Now there are 2 to 6, which are 65, around about 65,536 possible addresses within this subnet. Perhaps I will do, yes, a lot of people kind of struggle with subnetting, so I might do a subnetting class here for you guys, so just so that we can understand here subnetting and IP addresses and subnets, and it is a very critical component that we need to talk about, right? That it's not only for cloud, it's also for cybersecurity and networking and in general for the whole internet. So it's important that we understand this concept, okay? So let's see here. So a smaller CIDR block like 10.0.0.0/24 means that the only last 8 bits can vary, while a larger CIDR block like 10.0.0/8 gives you 24 varying bits, right? So let's see what we have here. So it looks like we have different CIDRs here, blocks. We have a /16, a /24, and a /8. Right, the number of fixed bits in this case would be the first two octets, right, or the first two numbers, and the rest are going to be bits that we can play with, right? Now it says here that what are the ranges, right? So on the /16 you'll have these ranges, on the /24 this one, and the /8 this, okay? So why do we use multiples of 8 or 16? We don't always need to use those, but those are called classful. I should mention it here. While CIDR blocks are often seen in common multiples of like 8, 16, 24, they can actually be any number from 0 to 34. Okay, the reason why multiples of 8 are popular is because each number between the dots is an IPv4 address. In an IPv4 address is actually 8 bits, right? A bit is a digit in the binary system, the language that servers and machines use to understand code and IP addresses. So 8 bits can represent any number from 0 to 255. That's why IP addresses start from 000 all the way to 255s, right? An entire IPv4 address is made up of 4 times 8 of that 32 bits, right? So these are different. There are 4 octets, right? Because each octet has 8 bits, right? So that's what I meant to say earlier, right? So let's continue here. Let me take a screenshot of the setup page. So we'll do, if you don't have this tool for screenshots, I mentioned it before, it's called GreenShot. It's completely free and you can take screenshots here. Okay, so VPC setup, and let's go back here and VPC setup. Okay, now what is an IPv4 CIDR block? To set up my VPC, I had to define an IPv4 CIDR block, which is a subnet that we just subnet range that we can use to assign to resources. Okay, so create subnets, right? Step number 2. Nice. So we've created, let me just go ahead and hit create VPC. So we have our first VPC successfully created, right? So which is like setting up a brand new city in your AWS region. Our new city is just a big open space until we organize it into different neighborhoods or areas. Your next step is to divide this large space into subdivisions called subnets, so you can start planning where different resources will live and operate. So it says here, launch a subnet inside your VPC. Okay, so we have deployed our first VPC within our closest region, right? And now we are going to create our first public subnet. Subnets are subdivisions within your VPC where you can launch AWS resources. So we're going to head to subnets, and it looks like it's going to show us some subnets already in fact, there are different subnets already created. So let's see what they are all about here. Okay, so what are subnets and why do I need them in my VPC? If your VPC is a city, subnets are like different neighborhoods inside your city. So you use subnets to group resources with similar access rules and restrictions. Some subnets might be public areas that all resources can access, like public subnets, and while others are private areas with limited access, right, which are called private subnets. A VPC can have as many public and private subnets as you need, but subnets in the same VPC cannot have overlapping IP addresses or an IP address CIDR block. This means that each subnet must have a unique range of IP addresses. So how are they already subnets there? The default VPC in your account comes with predefined subnets in each availability zone of a region, which means you'll see 3 subnets on your page if your region has 3 availability zones. Okay, what are availability zones and how do they affect my VPC? To understand availability zones, we'll zoom out of our VPC to look at the wider picture of an AWS region. An AWS region is made of clusters of data centers dotted around the region. These clusters are what we call availability zones. When you create a subnet within your VPC, that subnet has to fall under a specific availability zone instead of the entire region. By spreading resources across multiple availability zones in the same region, you are essentially creating backup options, right? So like this is used for high availability, right? So when you are creating a cloud infrastructure, right, you don't want to have all your resources or all your eggs in one basket, right? You want to have certain resources in one availability zone and then the other part of your resources in a different availability zone, just for redundancy purposes, right? So let's say, for God forbids, there is a natural disaster in one specific region or in one specific availability zone, and everything, goes bad, goes down, is destroyed, then you are still able to run your business because you have this backup, right? Like it says here, you have a redundant infrastructure that's available for you to continue use those resources. Okay, so by spreading your resources, if one AZ faces issues, others can step up to keep your application running without any issues for your users. Okay, so extra for experts. How can I find out how my ability zones are in my region? So let's take a look at this map. That's interesting. So in North America, right, it looks like we have a few data centers, right, and each data center has availability zones, right? As we can see, we have Oregon, Northern California, Golf Cloud, okay, of Canada, Virginia, Ohio, right? We have one in Mexico. Nice. Okay, so let's continue here. So what are subnets? Subnets are private areas or cities within our region that can be created within different AZs for redundancy, right? Great. Okay, so let's go ahead and create our subnet. So we'll select our VPC, which is this one, right? Now we're gonna give it a name. We'll just copy this and name it our next work VPC. We'll have to select an availability zone. In this case, we'll select the first one that shows, which is Virginia, right? Because that's the region that we've selected here. And then, before I continue, the reason why you want to pick the closest region to where you are is because it will make your infrastructure more reliable and more secure and faster, right? Just because the traffic that you are sending from your specific location to this data center will be faster and better, more reliant, as if you were picking a region that's further away, because if it's farther away from where you are, it's going to take different hops, right? Or different, it'll have to go through different data centers before it can hit that one, right? And that's the reason why you want to select the closest to you, right? So what is the CIDR block that we're going to use? Our VPC is that one, is /26, but for our VPC is /26, right? And here we're going to, can we modify this? Looks like we cannot. Okay, so that looks fine. Oh, here we'll do /24, right? Okay, so we'll create that subnet. We'll go ahead and launch it, and we have successfully created our first public, should be a public VPC. Okay, so why does that my subnet have the word public in it? Subnet could be private or public, right? And I explained this earlier. A public subnet is connected to the internet. Resources inside a public subnet can communicate with external networks, right? So as I mentioned earlier, I gave that brief explanation or example of how we are able to, how we can use a public subnet to be able to get these resources from the internet to for patches or updates for our application. Okay, a private subnet, on the other hand, does not have internet access, and you use it for internal resources that don't need to be publicly accessible. So for example, a database, right? Database usually contains very sensitive data, but for example, if you're running a web app, the public facing website needs to be accessible from the internet, right? Just so that people like you and me can access that specific website, right? So an EC2 instance hosting the website should be launched on the public subnet. On the other hand, when the web app's database that's storing sensitive data shouldn't be directly accessible from the internet. It only needs to communicate with the EC2 instance, so it can sit in the private subnet, right? So for example, when you are creating an account, let's say with AWS, right, you're entering your email and your password and other personal information, right? That personal information will be stored in a database that's connected to the website, right? Because we need to authenticate you on the website, but it has to be private, right? So it will only communicate with your EC2 instance, but it will be accessible through the internet. Okay. So while your subnet is labeled public 1, it isn't a public subnet yet. We still need to connect it to an internet gateway to call it public. Good point, which you'll attach in a minute. Okay, so start with your response. So what is your subnet not considered a public subnet yet? The difference between public and private subnets are the public face the internet, while private can be accessed only internally. Right? Okay. So what do we have here? So it looks like they're giving us 3 different regions, right? So your VPC has a CIDR block of /16, which gives you 65,000 IPs, and you can allocate these individual and you can allocate it to individual resources within your AWS account ranging, and these are the IP ranges. 2, you set up a public subnet called public 1 with a CIDR block of /24, and this is going to give you only 256 IP addresses that are reserved for resources launched in public 1, with addresses ranging from this to this. Then, okay, so it's the same region. Okay, so here they're referring to just the VPC. Here they are referring to just the subnet. And here is what we have to assign. So it says here an EC2 instance that get launched inside your public subnet, public 1, will be given one of these 256 IP addresses within public 1's subnet range. Pretty self-explanatory, right? So what we're going to do next is enable auto assign public IP addresses from our first public subnet. So we'll select here and we'll do actions, and it says that we have to go where to edit settings, subnet settings, right? So we're going to enable auto assign public IP addresses. So I would assume that what this means is that when you are deploying let's say an EC2 instance, it will automatically provide or assign an IPv4 address from the range that we have created, as opposed to us doing it manually. Okay, so that makes sense. By default, your resources already have private IP addresses, but this only allows internal communication within your VPC. To access the internet or be accessible from the internet, the instance would need a public IP address. When you enable auto assign public IP address for a subnet, any EC2 instance launched in that subnet will instantly get a public IP address, so you won't have to create one manually, right? So let's take a screenshot of that, and this will be the last thing I do here before I take a break. So subnet 1, and we'll go back here, and we have that. So why would you enable? Okay, so once I created my subnet, I enabled auto assign public IPv4 address. These settings makes sure that it automatically has a to a resource as opposed to okay. So we'll stop right here and we'll continue in just a second, guys. It looks like step 3 is going to be our last step, and here is that we'll be able to go ahead and create that internet gateway so that we can get access to the internet. So I will see you guys in just a little bit.